Alright, hello. My name is Andrew Akin, and this is my programming project. So looking at my program here, I have the main sequence star calculator from the IB handbook using those equations. So what you're going to first want to do is turn on the functions. So let me run this program and bring it to size here. Alright, so first things first, you're going to want to turn on the program. Give it a second to load. My computer is ancient. And that's going to enable your green light. So when you have a function here, it's going to enable your functions, so only when that green light is on, these inputs will pull out to those outputs via these buttons. If you don't have it on, for example, and you have the parallax angle set to 0.002, and then click on distance, you get nothing. Whereas opposed to if you click on the enable functions to turn on the calculator, 0.002 distance, then you get a distance value of 500 light years away. So another thing that I have incorporated here for use is if you're bored and just want to see how the values line up for these sort of calculations, if it's a main sequence star, is when you press the randomize for me button, it gives you random values in parallax angle in radians, which is basically the distance in radians for how far an object has moved based on a 6-month period around the sun. The radius of the star using the parallax. So if you have that value given, you can calculate the radius of the star. You can also get the temperature. So if you know the temperature of the star based on its mass spectrometry, you can punch that in for a value such as 4,786 Kelvin, which I believe puts you around red for the spectrum. So if I put those numbers in, distance, luminosity, brightness, and then the mass. So on an ideal main sequence star, these are the values that you would be getting. A mass of basically 53,000. And that would be in your, if I recall, kilograms. Otherwise, it is your astro units, depending on the size of the star. Sometimes, if you have a weird value that's put in over here, it usually results in a lower value over here. So going through it, you have your distance in light years, luminosity in watts, brightness in lumens, mass, and those are all your outputs. So as a neat feature I have here, where if you were to change the value for any sort of custom inputs, so say this is all 0, for some reason that doesn't want to update. So if you were to change this value to, say, a number that is under 2,500, so 2,400 for example, for some reason it does not want to update on me. But pretty much the gist is, if you were to start up this whole entire calculator again, run it once more, then if you were doing manual input entries, such as 2,400 for the mass, why is this? Well, I just had it working a while ago, so that, I don't know why. But if your mass is over X amount, so over 2,500 astrological units, or kilograms, that in essence could be a main sequence star based on our model. So when I go down to the plot initialize, this will give us a main sequence chart based on the log scale. Well, this isn't really log scale anymore, this is modified. I have it set where it automatically modifies down to the chart size, so that's easier to view. So once you have your values, say for example, do the randomized, look for something low in terms of the radians, put that at 002, put our kilometers at 5,000, put our temperature at 8,000. Distance, luminosity, brightness, that. So looking at our mass, we have 6 times 10 to the 4. Should be somewhere around here. Looking at our luminosity, which would be right around there, which would be our 7 point... Wait a second. So that would not be under the main sequence curve. That would be somewhere more down there. So this technically would not be a main sequence star comparing it to our main sequence chart. Right here I have a note which pretty much, once expanded, will let you know the size, or not the size, the information that you need to use this chart as well. Hopefully that helps.